All right, Math 5130, Statistics for Healthcare Professionals at Shawnee State University. My name is Doug Darbrow. I have been asked to develop this course for the graduate programs, potentially in nursing, occupational therapy, and health sciences. Let's dive into what you can expect. So for 5130, you can expect 7 lessons, and within each lesson, there are going to be instructional videos, just like this one. I try to keep the instructional videos around 15 to 20 minutes. Not sure about you, but I have attention span issues, so I try to keep these manageable. There will be supplemental resources. I'll point that out in an intro video, which I'll post later, and it'll be available for you once you're taking the class. And again, you have to keep kind of the time context in mind. I am creating these videos creating this course in November of 2023. I expect the videos to be around a while, so if you're watching these in 2028, then just add 5 to everything that I tell you. But again, supplemental resources will be available. There will be a MyStatLab assignment. So from now on, when you see MSL, that stands for MyStatLab. It's a Pearson product. More about that later. I'm not going to expect you to do anything that I don't demonstrate to you. And there will be a DF post in every lesson, and that is submitted through Blackboard. There are also exams and projects. I haven't yet landed on what I'm going to do there, whether there will be just a final project and no exams, or 2 exams and no project. But by the time you take the class, that decision will be made. But again, keep in mind the context. I'm developing these videos, developing this course in November of 2023. I think the major challenge in creating, again, I'm a statistician. I have taught for almost 30 years at Shawnee State in the Department of Mathematical Sciences. I've taught primarily, solely to math and statistics majors. I primarily teach in our graduate program now. So in developing a class, it's going to be delivered to people who really don't want to become statisticians or mathematicians, but need to use statistics to further knowledge within their field, namely occupational therapy, nursing, and health sciences. I had a couple of dilemmas. And I guess my first dilemma is just how much review to cover, because I realize that students in these programs are going to come to me with different backgrounds. Some of you will maybe have a statistic class, last year. Maybe some of you it's been 15 or 20 years. So it was difficult to decide, narrow down what to include in the review. The second thing that I struggled with was which statistical software package to use. Ideally, I would have used SPSS, but SPSS is quite expensive, so I landed on using StatCrunch, which is included in the Pearson product, MyStatLab, and I'm going to demonstrate R, which requires a little bit of coding, but I will never ask you to do anything in R that I don't show you how to code that. So again, I'm Doug Darbrow. I think in January I will have been at Shawnee State for 30 years. So January of 2024, and I work very, very closely with occupational therapy and nursing to develop, statistical content. So let's get started. I'll go ahead and file a disclaimer here. I'm not a big fan of PowerPoint, but the first probably 4 or 5 instructional videos, I'm just throwing content at you that just needs to be written out, right? And I promise you, I'm not going to read to you. I hate people that prepare PowerPoints and then just sit there and read to you what's on the PowerPoint. So I'm not going to do that. I encourage you to take screenshots, get organized with your notebook, and I'll provide some other hints and tricks for success in another video. So what is statistics? I think of statistics as the science of collecting, analyzing, and interpreting data. We want to collect data that's representative of the population we wish to generalize to. If we, for example, come up with an idea for some sort of medical care to elderly patients, well, we wouldn't want to go out and collect a sample of children. We wouldn't be able to generalize effectively. We wouldn't be able to generalize at all. But anyway, once we collect our data, we want to learn how to analyze it and interpret in the context of healthcare situations. Data is just things that we collect on, dogs, cats, trees, cars, hospitals, nurses, doctors, different things. And in this class, we learn to analyze data. Population is the entire group of subjects, elements, dogs, cats, trees that we want to make a statement about. And this is something that people overlook a lot in clearly defining their population. For example, let's say you're interested in some sort of employee satisfaction survey rating, and you want to give this to nurses. So the population you want to generalize to is all nurses. Well, then you would need to get a random sample from all nurses. In other words, that nurse in Utah would have equal chance of being in your study as a nurse in Tennessee. Now, if you're just wanting to look at the satisfaction survey of a particular hospital, then your population is all the nurses in that particular hospital. And then you would just take a sample of nurses from that hospital. But in generalizing the results of your study, you would have to be very careful and not overgeneralize. But more about that later. A sample, if you collect data from every member of a population, so if you, for example, work in a small hospital and you have access to every single nurse, kind of playing off the example that I just gave, then you're giving actually what's called a census. But if you go into the hospital and take a sample of nurses and give them the survey and use statistical procedures to generalize to the nurses in that hospital to make a statement about all nurses in that hospital, then you're taking a sample. So the goal in statistics, almost everything that I'm going to teach you in this class, is all about a simple statement, using sample data to make a statement about a population characteristic. Hospital survey. So there's a survey that asks people to report on their recent experiences. So this is for patients. A survey was given to all patients in a regional hospital who, I told you I wasn't going to read to you, and look what I'm doing, received inpatient health care during a recent month. 217 patients responded to the survey. Not all patients responded to the survey. Identify the population, identify the sample, and is the value of 217 a statistic or a parameter? Now, let's jump into it. Identifying the population is extremely tricky because that would be framed according to the intent of the study. The way that this is presented to me, I assume that the population is patients from this particular regional hospital. We couldn't generalize the results to patients at all hospitals because, again, we have what's called a nested design, and our patients were selected from one regional hospital. So the best we could do is to use our results and generalize to that particular hospital. The sample is the 217 patients. Is the value of 217 a statistic or a parameter? We'll get into this a little bit more, but for now, if a value comes from a sample, it's called a statistic. If your value represents a population, then it's called a parameter. So the 217 comes from a survey response to the 217 patients in our sample. So the 217 would be a statistic. Now, facts, one of these things that you just need to tattoo to the brain, the most effective way to reduce bias. Now, what's bias? Bias is just a difference between what our results tell us and the truth. So anytime we conduct a study, one of the primary goals of our study is to create and develop a study that reduces bias. We don't want a difference between what we find and the truth. We want those to match up and be very similar. So in this example, do we have a random sample? If not, what kind of sample do we have? Well, we have what's called a convenience sample, because what they did is they just took a month, they sent out these surveys, and so it was just like we didn't do any random sampling or stratified sampling. Again, more about that later. We just had a sample in 1 month because it was convenient to us. And it was also a voluntary response sample, since we sent these, well, at least the way they framed the study, they sent these surveys to the patients and they could respond or not respond. Would you feel comfortable generalizing these results? I would not. The most that I would be comfortable doing in this example is to just make a statement about the 217 patients who responded. But in terms of generalizing to all patients at this hospital, I would not feel comfortable. How could this study be improved? I would say instead of over a month, I would maybe over a year, take a random sample, and I would, you'd probably still have to have a voluntary response sample, but I wouldn't choose a sample from a particular month. I would do it over a longer period of time, and my sample would be random. All right, let's talk about once we get our data. So what I have here is, looks like we have 8 patients, all female, with the systolic and diastolic blood pressure measurements. So what are your cases and what are your variables? Of everything I'm going to teach you in this video, I think this is probably the most important, because this is something we have to be able to wrap our minds around in organizing our data before we can correctly analyze it. So the very first thing that you need to start thinking about is when we have our data in the other form, we need to get it in this form immediately. Now, what's the difference? The difference is when we read left to right, all the information on that particular line represents that particular person. So if I come down to 3 and I read from left to right, this patient or person has an ID of 3, which is just kind of randomly assigned. Now read over. The F stands for their gender female, 138 systolic, 80 diastolic. So when a data set is in the form that is appropriate to analyze it, this is the format that we'll have. So when we read left to right, those are called our cases. When we read up and down, those are called our variables. So the cases here are people, they're female. We have 8 cases, and we have 2 variables. Now you might look at that and think, well, wait a minute, I can count, and I see 3, gender, systolic, and diastolic, right? But if we look at gender and look down through there, we see all Fs. A variable must vary, and gender does not vary, all the same gender, and so that's not technically a variable in this study. We can't analyze any variation within gender because of no variation. Systolic and diastolic are both quantitative. We'll get into a lot of situations where we have categorical variables. So again, how many cases? 8. How many variables? 2. So research actually shows when people without a background in statistics read a data set like this, they typically read left to right. In other words, you come down, you get all the juicy gossip. One number 6 ID, that's a female, and blood pressure is quite nice, 100/80. Um, we get that, but statisticians could care less. If I do my job correctly, and I will, when you look at something like this, you're not going to even read left or right. You don't even care about it. You're going to read up and down. So when I look at systolic and diastolic blood pressure, I start thinking about, well, what's the average? What's the median? What's the variability? I start asking questions about vertical relationships and not horizontal. So what are the cases and variables here? Cases aren't always people. So this is an interesting data set, actually in StatCrunch. And when I read left to right, I can see that the cases here appear to be different facilities. It looks like we have 42 healthcare facilities that are included, so we have 42 cases. The variables, so we have facility, insurance, sex, I assume that's length of stay, the day admitted, the discharge date, the birth weight, and I assume total CHAR is the total charge for the hospital stay. So I have how many variables? I have 1, 2, 3, 4, 5, 6, 7, 8 variables. I see that birth weight and total charge are quantitative. Length of stay is quantitative. Gender, sex, even though it's coded as zeros and ones, which are numbers, is actually categorical. Sometimes we get into data sets which represent categorical variables as numbers. I don't like that. I would use F's and M's or non-binary, whatever, however you coded that. Insurance, facility, those are clearly categorical, and admitted and discharge dates are clearly categorical. So the point here is cases aren't always people. Oh, wow, okay. Cases aren't always people. Cases can be, as in this case, medical facilities. All right, that's the end of, came up on me. I thought there were more slides. All right, take care.